Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we are going to see about file programming in C. Files are a very powerful feature that any programming language has to offer. Files are a means of storing information. So, we will see how these files provide us with useful programming features when we program using this programming language. Data files. The most commonly used type of files are data files. Information is stored on the memory device in the form of a file called the data file. Data files allow us to store information permanently. We can access and alter that information whenever it is necessary. So, files not only provide a means of storing information permanently, they also allow us to access that information, update that information or delete that information permanently. Moreover, files are a means by which we can easily access as well as store data. So, why do we have to go in for these files, and what are the other means of storing information on a computer that differentiates between the information that is stored on a file and the other means? There are 2 types of data files in C. The one is the stream oriented data files, that these are the standard data files that are used in C programming because they are easier to work with and they are more commonly used. Easier to work with in the sense they have more or less the same protocol for all the operations that are performed on these C files. The other one is the system oriented or the low level data files, wherein they use very low level language statements which is difficult for the user or the programmer to understand. So, in such a situation it will be more difficult for them to remember the kind of statements that are to be used, the syntax that is to be used while working with them. So, most of them prefer to go in for these stream oriented files which are the default mode of operation when we use files on C. So, we will now see about these stream oriented files. Within stream oriented files also there are 2 categories. One are the text files, the other is unformatted data files. So, from these 2 difference itself you can identify that text files are a kind of formatted ones. Formatted in the sense they follow some kind of a format while storing information, and data that is stored in these text files is easier to be identified separately because they have a certain format of storage. It is easier to identify each piece of information within a text file. Whereas in unformatted data files the format is not specific. So, you just store information in it and it is stored permanently, that is it. So, now text files, they consist of consecutive characters, that is successively, continuously you can keep storing information in these files. The manner of interpretation, so when you store data in these text files, how does the user or the programmer interpret it, or how does the computer interpret this information? See, they are formatted type of files. So, though you store information continuously, there has to be some meaning to the information that you are storing, because data with meaning is what we call information. So, how does the system interpret the data that is stored in these files? The library functions that are used to transfer the information is one way the computer interprets it. So, library functions are system defined functions, they are already existing in the language. So, based on the library functions, now we will be seeing what are library functions we are going to use on files. Based on the library function that is used in the program, the data within the text file is interpreted. That is, the computer will identify what data within the data file is required by this library function. The second mode is the format specification. Format specification within the library function. See, all library functions will not have the same syntax. One library function will have only one argument. For example, fopen will only have the name of the file and the mode in which the file is to be opened. Whereas fread will have the name of the file, at the same time what is to be done with the information that is read, how many characters are to be read. Like this, the arguments will differ. So, based on the format specification, how the library function is formatted, the computer will interpret the interpretation of the data. It will interpret how the data is to be accessed, updated or used. So, the type of interpretation depends upon the library functions as well as the format specification within the library function. And finally, they are interpreted as individual data items or components of strings. So, this is the final type of interpretation. Because the characters are stored consecutively or successively in a text file, how do you separate it and retrieve it? Whether you are going to separate it as individual characters or individual lines or individual statements, or whether they are going to be a component of data strings, or whether collectively they are going to make meaning. So, how does the data in the file identified and provide meaning to what is being done, to the operation that is being performed, whether you want to retrieve one word, or you want to retrieve only one alphabet, or you want to retrieve it collectively as a paragraph. When does it make meaning? So, this is the meaning of interpreting the data items in a text file, and there are two ways to do it. Next, unformatted data files. So, in unformatted data files, what is being done? How is it organized? This organizes data into blocks. So, like memory partitions, memory is divided into different blocks, isn't it? Like that, these files also, the storage in these files is in the form of continuous allocation, continuous blocks of memory. You cannot separate words or alphabets from them. They are all pushed together in one block. Blocks contain continuous bytes of information. So, that is what make a block, continuous bytes of information. These represent more complex data structures like arrays and structures. So, we have studied about what are arrays and structures in C. So, here you cannot store individual letters or alphabets with some meaning. They will not make meaning in unformatted data files. Unformatted data files are meant for blocks of information. So, when they have to make meaning, it obviously has to be some data structure. A continuous group of 5 bytes forms an array. So, that alone has a meaning. Taking one element from an array and expecting it to do something is not going to make sense. Then there is no point in using arrays. We go in for complex data structures only because we need operations that involve so many bytes of information. So, in unformatted data files are used for storing such types of information. A separate set of library functions is available for processing such data files. So, that is another difference between the text files and unformatted data files. The same library functions are not used here, because here we are not going to access individual data items. Whatever operation is done in a collective manner on the entire data structure. So, obviously the operations have to have a different format, either more number of arguments or more number of pointers and so on. So, the kind of library functions are also different for both. Next, we go on for these low level data files, system oriented data files. They are complicated to work with, and a separate set of procedures with accompanying library functions is required to process these files. So, as I mentioned before, this is what makes it more complicated. You do not just have f open and it opens a file, f close and it closes a file. You have a separate set of procedures. A procedure is nothing but a function by itself. So, when you have to work with these system oriented files, it is like memorizing another function with complicated syntax. So, studying that itself is a Herculean task. Then you have to use those functions in order to work with these files. So, the time taken is more complicated, the work that is being done is complicated, and the work that you do has to be understood by the user who has to work with these files. So, that is another difficult task. That is the reason we do not go in for these system oriented data files at all. Next, we have what are called binary files. So, these are different from text files. In data files, you have stream and system oriented. In stream, you have text and unformatted. Now, these binary files are different nature of files because it stores different type of information. Data which are related to numbers, numeric values, can be efficiently stored in the form of binary files. So, this is mainly used to store numbers or mathematical information. They are useful to handle file containing machine language contents. So, normally when you run a C, C++ or a Java file, you will see that in your memory you actually created only one file, either .java or .cpp or .c. But when you run it, that is when you compile it and it is successful, that is the compilation is successful, there are no errors in your program, you will see that in your storage there will be two more files, .bin, .exe, .bak and so on. So, all these are called machine language files. They will have information that we cannot understand. It will be understood only by the system, because the information that is present in these files will be in the form of machine language contents. So, these are also binary files. So, binary files, when it comes to the user, mostly we store only numbers, and in addition to that, when we write some program, we store it, we compile it, we see that it creates binary files which indicates that the compilation is successful. So what are the advantages of using these files in C? They are a permanent storage of data. They store large amount of output. So for some files, if you see, the output will cover the entire screen. So in order to store it permanently, we have to write it on some paper, or in order to remember it, we have to make a point that so much of output has been generated. So in order to avoid that work by the user, we can store such large output in a file itself. So it will be permanently stored. Whenever we want it, we can use it. Storing large input for repeated execution of the same program. See, when you want to know whether a program is working correctly, you won't just execute it once. You will execute it with different types of inputs and see whether the program is working correctly for all the outputs. This is okay when you are having small inputs like addition or subtraction, something like that. But when you are having a large input, for example, when you use data structures, you have these knapsack problems, traveling salesman problem and so on, where either the output will be large, or in certain problems you will have a large input to be given. It will continuously ask you certain questions and you will have to keep answering them. So in order to avoid such repeated manual information by the user, you can store the input in a formatted manner in the files itself. So what the program will do, it will be directed to the file, it will take the input from the file, it will execute it, and whatever result is obtained, that also it will store it in another file. So here if you see, the programmer's intervention is very less, or the person who is using the program's intervention is less. He neither has to give the input nor the output. He just has to write the program in a manner so that fetch the input from the source file and store the output in the destination. So this is another advantage of using files. Transfer of input and output data from one computer to another is also easily done. So when you have to store transfer information, move information from one PC to another, either in a network or across a network, it's easy to do it using files. You just have to transfer the file name. You don't have to transfer individual contents. So these are the advantages of using files. Next we will go on to see how we read and write from files. Welcome back after the break. Before the break, we had a brief introduction into the file system in C. So what are the advantages of using files? What are the types of files available in C? The data files, stream oriented, system oriented, text files, unformatted data files, and binary files. So we have identified that standard file for usage in C programming are the stream oriented files. So now we will see what are the operations that are done on these stream oriented files. Before we start performing operations on files, we have to first establish what is called a buffer area. So what is this buffer area while using files? Buffer area is where information is temporarily stored while being transferred between the computer's memory and the data file. So buffer is nothing but a temporary storage of information. It's a temporary storage area in memory where information can be stored only for a small amount of time. So this is normally done during transfer of information, like you don't have to go to the computer's memory, access the information, take it and store it in the data file, and back again from the file to the memory. We all know that the computer's memory is a slow working part of the computer. Accesses to and from the memory are quite slow. So when you have to transfer information, if you are going to keep doing it time and again from the computer's memory, it is going to be a very slow process. So in order to avoid that, we go in for this buffer area where information is temporarily stored, at the same time there is quick access also. So when you are transferring information, it can be done in a faster and more efficient manner. So that is what we call a buffer. This buffer allows information to be read or written more rapidly. So while performing operations with files, we don't want the advantages to be overcome by the disadvantages, because if the operation is going to be very slow, the user is going to get irritated. We all use the computer only because it is a fast device. So when we go in for file operations, it offers all advantages of permanent storage and so on. So the speed also needs to be quick. That is why before performing file operations, we identify a buffer area which is free and we store information in it, transfer information from it in a very fast manner. So we will see how, using syntax and statements in C, we are going to establish this buffer area and complete the operations. So to establish the buffer area, this is the syntax: file, a pointer variable and a variable name. So this file always needs to be in uppercase. C is a case sensitive language. So we have to make sure small letters are always different from the big letters. So file should be in capitals followed by pointer variable. The variable name is as we wish. So what does this file do? This is what actually establishes the buffer area. So when the C compiler sees this file keyword in your program, it will immediately try to identify a buffer area. This buffer area is a special structure. This file, FILE in caps, is already having a predefined meaning which is stored in this stdio.h header file. ptvar is nothing but a pointer variable name. Pointer is indicated by the operator, the indifference operator, pointer variable operator. The pointer indicates the beginning of the buffer area. So the buffer area is established, we need to know where it is. So in order to point to that location only, we have this pointer variable, so that the program will know where it has to store the file contents. This ptvar is a stream pointer which is defined in the stream classes in C. So a data file must first be opened before it can be processed. Generally all the files will be closed in the system. So when you have to operate on certain files, you need to explicitly open those files. So what are the operations involved in opening a file? It associates a file name with the buffer area. See, you have the area in memory, you have a pointer to it. You should know which file is stored in which buffer area. There will be plenty of files, thousands, lakhs of files in a computer. So all the files are going to be closed. At one particular point of time, 3 or more files may be open and many buffer areas may be present. So you have to know which file is being stored in which buffer area. So you have to associate the file name with the buffer area. Then you have to specify how the data file will be utilized. So when you are opening a file, you should indicate whether the file is only going to be read or whether it is going to be written or whether some data is going to be updated. Because only when you tell all these things, the computer will make sure that the consistency is maintained. Because one person cannot open the same file for writing at the same time. Then the data of the file will not be secure. 2 or more users can write whatever they want into that file and they can save it and go on. Then there will be no data consistency. The computer will not know which data has to be permanently stored when 2 or 3 people are making changes. Whereas the same file can be opened for read purpose by more than one person, because they are only going to read the contents, they are not going to change it. So any number of people can read it at one time, but only one person can use the file for writing or appending at a time. So it is very important to indicate whether a file is being opened for reading, writing or updation. So these are the 2 operations that are to be kept in mind when we want to open a file. So the normal operations that are done are reading, writing or both. So this is how the syntax is given. ptvar is the variable name, is equal to fopen is the library function, followed by the file name, followed by the file type. File type is nothing but the type for which it is opened, reading, writing or whatever. File name represents a file name. File type represents the manner in which the file is utilized. File type specification. So as I mentioned, how the file is going to be utilized, there are 6 different ways in which the file is utilized. So now we will see each of them. R, when you give R as a file type, it indicates that it is opening an already existing file. This is very important. You cannot read a file which is null or which is empty. It is going to waste your time. So before you open a file, you have to know whether it is having some contents. So it opens only an existing file for reading. If the file does not exist, then it will return an error. W opens a new file for writing. So here again, this has to be a new file. When you want to write something, it has to be a new file. If a file with the same name exists, that file will be destroyed and a new file in its place will be created. So this is another point the programmer has to keep in mind. If he is going to give the same file name to a file to be written, then if any file is existing in that same name, it will be destroyed even without his knowledge. So you have to make sure that when you are giving a file name, that previous files don't exist in that name. In case they exist, then you have to make sure that they are not needed any longer, because they will be destroyed. So when you are opening a file for writing, you have to be sure of these 2 things. Next is A. It opens an existing file for appending. Appending is nothing but adding contents to the end of the file. If the file does not exist here, again a new file is created in its place. R plus, it opens an existing file for both reading as well as writing. W plus opens a new file for both reading as well as writing. If a file with the same name exists, it will be destroyed and a new file will be created in its place. So that is the difference between R plus and W plus. In R plus, there has to be an existing file. You cannot open a new file. You cannot create a new file and open it for reading and writing. Whereas in W plus, you can open a new file for reading and writing, and if the file exists with the same name, it will be destroyed. So that is the difference between both. Though the operations are the same, the manner in which the compiler interprets it are different. Then you have A plus is nothing but for appending. So it follows the same rules that we follow for A. You can append the file, you can write into the file, and you can read the file as well. Here again, if a file with the same name exists, it will be destroyed and a new file will be created in its place. And these are the two library functions, fopen and fclose, for opening and closing files. Fopen is nothing but this function returns a pointer to the beginning of the buffer area associated with the file. So we associate a file name with the buffer area, and when we want to read or write or do some operation, you have to point to the beginning of the buffer area, because you have to either read from the beginning, isn't it? And if you have to write also, you have to write from the beginning. Only for appending you have to go to the end of the file. A null value is returned if the file cannot be opened. Either it does not exist or there is some problem, it is locked by some user, you cannot open it at the time for reading or writing, or some other person is using the same file for writing also, you cannot open it. So these are, in such cases, a null value is returned. For fclose, a data file must be closed at the end of the program. Once all the operations on files are closed, you can either individually close each file, or you can give fclose all, which will close all the files that are currently open for the particular program. So fclose ptvar, which indicates the pointer variable associated with the file name. So these are the syntax to be followed while processing files. So this is an example of how files are used in C. You have the header file, you have null, you are defining the value for null. It is sometimes not necessary because null is already defined in C. You have the main function, here you have the file star fp. So here you have to keep in mind this program will lead to an error, the reason being file is in small case. File should always be in capital letters, only that is the way it is defined in stdio.h file. So here you have to make sure that file should be in caps. Then you are going to open the file the same way. Fp is the pointer variable, fopen is the library function, test.dat is the name of the file, r plus is the mode, which indicates that the file is to be opened for reading as well as for writing, and the file should exist. If fp is equal to null, that means if the file does not exist, it gives an error to open the file. Otherwise, it does whatever has to be done, either you can read from it or you can write from it or do whatever you want. And then you have to close the file using the pointer variable fp. So this is only a skeleton of the program of how you normally open and close files. Next we move on to reading and writing files. What is to be done when you write into a file? It has to be opened in the write mode. If the contents to be stored in the output file are already known, the file cannot be created using a text editor or a word processor. Like certain types of data in the files, you can know what is to be stored inside. So what you do is, using a text editor itself, you can store the data and you can save it in that name. But in most of the cases this is not possible, because based on how the program executes only you will know what data is to be generated. So only when the contents are already known you can store them using the text editor or word processor. Otherwise, if the contents are computer generated based on the program, then the output file can be created only with the help of a program. fprintf statement is used to write into a data file. Normally writing on the output screen we follow printf, but while writing into a file you follow fprintf. After storing the output of every fprintf statement, the internal file pointer advances to the next location automatically. So when you are writing into data files, once one line is completed, automatically the pointer will move to the next space, the next line. You do not have to worry about it. So this is another advantage with files. The fputc statement also performs the same function as fprintf, but only thing, the putc statement can write only characters. The printf statement can write characters as well as numbers, whereas putc statement can write only characters into the file. So the only difference is that you have to prefix an f to the functions. Instead of printf it is fprintf, instead of putc it is fputc. So these are the points to be kept in mind while writing into files. Reading files, the fscanf statement is used to read from a file. Every file stored in the computer is terminated by placing a special character at the end of the file. This is the end of file character, EOF. The FEOF function checks whether the file end has been reached or not. So, when you are reading from a file, you have to stop when the file is over. So, for that reason only you have this FEOF function. This will identify when the file ends. This is possible because an EOF special character is placed at the end of each file automatically by the C compiler itself. So, now we will see an example of how to read and write from a file. We have the main function. Again here the file needs to be in caps, file, pointer, indifference pointer, fn and fout. Fn is for opening the file, fout is for closing the file. Then you are having average, value and sum, both of them are, all the three are float values and sum is initialized to 0. So, in this program we are going to have a set of values in a file which we are going to read, we are going to compute their sum, compute their average and we are going to store it in another file. So, how are we going to do it? We are going to read and write from a file. Count is initialized to 0, count is nothing but the number of numerals that you are going to add, the number of digits you are going to add, because if you have to compute the average you need to know both the sum as well as the number of numbers, number of digits. So, that is the reason you have these many variables. First you are going to open the file from which you are going to read the digits. Fn, fopen, ex1.dat is the name of the file. You are opening it in the read mode. You are checking whether it is equal to null, that is whether the file exists or not. If the file exists, whether there are any contents in the file. So, that is what is checked in this if statement. If it is equal to null, then you have to print that you cannot open the file. If there is some content in the file, if the file is existing, then you go in for else statement where till the file end is reached. So, file end of file function is checked over here, while not equal to file end of file. That means as long as file end of file is false, as long as there is some data in the file, you are reading it using the fscanf statement. Fscanf, fn which indicates the file, %f which indicates the type of values you are going to read, ampersand val. So, val identifies each value that is being read from the file. All the values one by one, as you read the values, they are added to the sum variable. Sum is first initialized to 0. So, suppose you read 5, it is added to sum. Next you read 10, it is added to the 5 already stored in the sum. So, it will become 15. So, in this way the loop goes on executing till the file end of file is reached. You are also incrementing the count value. So, for every digit that you read, the count value is incremented by 1. So, now in a single while loop, you have both read the file, you have summed up the values that are being read and you also have a count of the number of values that you have read. So, now it is easy to find out the average. You both have the sum as well as the count. So, in the next statement, you are calculating the average value. Now, what you have to do? You have to store the data back into another file. So, fput is equal to fopen, you are opening the file for writing. So, fopen res.dat, this is another file, the destination file. For write mode, you are checking whether it is null or not. So, here if you see the statement, you are having fput is equal to fopen, that is you are checking whether opening this file res.dat is okay for writing into the file. So, that is the reason you are opening the file in the write mode, checking whether it is equal to null and whether the fput statement can write the data into the file. If this results in null, then you have to print the statement cannot open file. Otherwise, you use the fprintf statement. Fout indicates the file name, what you want to print, averages %f and you print the average. Then you close fn, you close fout and getch is to obtain the result. Instead of using this fclose fn, fclose fout, you can also use fclose all. So, this is how you read using fscanf and you write using fprintf. And you have to check for the values of whether the file exists and whether it can be read and whether the file is existing for us to write into it. So, checking both the options, you are reading and writing from a file. So, in today's session we have seen about the basic types of files in C, the open and close functions fopen and fclose, the read and write functions of C. So, the possible questions that could be asked in the session are the types of files in C. The list of type of files in C: stream oriented and standard, data, text and unformatted data and binary files. The advantages of using files: permanent storage, to store large output, to store large input, and for transfer of files to and from one computer to another. How to open and close files? This is using the fopen and fclose functions, and every time we use the fopen and fclose functions, we have to check for the error conditions also. The ways in which a file can be utilized: for reading, writing, as well as for appending, or for both the purposes at the same time. What are the functions available to read and write files? fscanf and fprintf statements. Fscanf, we can also use fputc and fgetc, but they can be used only for reading and writing characters, whereas fscanf and fprintf can be used for any type of data. So these are the normal questions that could be asked from this session, and we will see about the other types of files, the binary files, and how to process data files in the next session. Thank you.